Hi friends, in this video we will discuss the time domain representation of LTI systems, that means linear time invariant systems. So these systems are linear in nature and time invariant, so they are not varying with the time. So how to get the time domain representation of linear time invariant systems? First we will discuss the significance of this time domain representation of linear time invariant systems. Yeah, the focus is on system descriptions that relate the output signal to the input signal when both are represented as a function of time. As these things are time invariant systems, so they can be represented as the function of time. If both input signal and the output signal are represented as the function of time, then what is the system description? That means how to get the if input and output are given to us and how to get the system description. So that thing is called linear, time domain representation. As they are represented in time, so we can call it as time domain representation. And the descriptions developed are useful for analyzing and predicting the behavior of LTA systems and for implementing discrete time systems on a computer. So actually two things are there in this discussion. One is continuous time signal and second one is discrete time signal. In both the things LTA systems are existing. So what is the main significance of this descriptions? What is use of describing a system based on the time domain representation? So the main useful thing is we can analyze and predicting the behavior of LTA systems. For example, if we have set of inputs and a corresponding set of outputs, based on these things, based on these relations, we can have we can we can get some description of the system. That means, for example, if the input is 1, 2, 3, 4 like that, and the output is 1, 4, 6, 8 in this way, then we can easily identify that the LTA system is the output is twice of input. So then maybe the system may be two times of the input. If I know that system, if some other input is coming, maybe some 100 is coming, so as I know the system, I can easily predict the output of the system. That means it is 2 into 100, it will be 200. Just like that, we can predict the behavior of the LTE system, and we can use this system with any of the inputs. As we know the as we can obtain the output, so for the required output we can have sufficient input, as we already know the description of the system. Coming to the discrete time system, what is the advantage? So if we have discrete time system, we can easily implement those discrete time systems on a computer. Okay, that is the advantage of the time domain representation. Yeah, the first and foremost method is the impulse response method. So characterizing an LTA system in terms of impulse response, defined as the output of an LTA system due to a unit impulse signal applied at t equal to 0 or n equal to 0. So impulse response means we need to multiply the impulse response at t equal to 0 for continuous time signal, or we need to multiply the impulse signal at n equal to 0. That signal has to be multiplied with our signal, then that output is called impulse response. So the impulse response is determined from the knowledge of the system configuration or dynamics. So we can represent the same thing with the knowledge of system configuration or dynamics, or in case of unknown systems. Yeah, if we don't know the system, then we need to consider the dynamics also. So it can be measured by applying an approximate impulse to the system input. So system input is there. For example, my system input is having some value at n equal to 1, n equal to 3 and n equal to 5, for example. So now we need to apply the impulse response. So if I apply the impulse response at n equal to 1, I may miss the response of my signal at n equal to 3 and n equal to 5. So what I need to do, I need to apply the impulse response at all the points. That means at n equal to 1, at n equal to 3 and at n equal to 5, and I need to combine those responses so that I can get the impulse response of my input signal. Yeah, given the impulse response, the output due to an arbitrary input signal by expressing the input as a weighted superposition of time shifted impulses. So what I have just now explained those things. That means if my system is defined at n equal to 1, n equal to 3 and n equal to 5, what I need to do to get the impulse response? I need to generate the impulse at each and every point, and I need to multiply them. Those things are called weighted superposition of time shifted impulses. So what I need to do to generate the impulse response means I need to shift my impulse response from n equal to 0 to n equal to 1, n equal to 3 and n equal to 5. And those things should be superimposed with some weights as a weighted superimpose. That means if at n equal to 1 my input value may be 5, what I need to do, I need to multiply this 5 with that impulse signal. That means what I have done, I have done it as weighted time shifted impulse. The time has been shifted to n equal to 1. That means it is the time shifted impulse, and it is the value has been multiplied. That means it is a weighted time shifted impulse. And then what I need to do, I need to do the same operation at n equal to 3 and n equal to 5. Finally I need to add them. So addition means superposition. So finally I can say that it is a weighted superposition of time shifted impulses. So in this way I can have the impulse response of my input signal or the system. So in this way this operation can be done in a fruitful manner for the time response, for the time domain representation. I need to use the convolution. So the convolution means it's the weighted superimposition. Yes, it is weighted superposition, and this weighted superposition is itself called as convolution sum for discrete time system. If it is a discrete time system, I can use sigma. So that thing is called convolution sum. Yeah, if it is a continuous time signal, I can't use the sigma, I mean summation. So I need to use the convolution integral. Yeah, this is coming to the second method. This is the first method what we have so far discussed, and that method is impulse response method. Now the second method, characterizing the input output behavior of LTI systems, is a linear constant coefficient differential or difference equations. So here we can use the differential equation or difference equations. Let us see. Differential equations are used for the continuous time systems, and difference equations are used for the discrete time systems. Obviously, the characterizing the solutions of differential and the difference equation with a goal of developing insight into the system's behavior. So obviously based on the systems, so depending upon the system's behavior, it is the equations are designed. So this method is the second method. So coming to third method, the third system representation is the block diagram representation. So it is the interconnection of scalar multiplication, addition, time shift for discrete system, and integration for continuous system. So this is the block diagram representation method. So this is the third method. So coming to the fourth method, the fourth method is the state space analysis. The final representation is state space variable representation. So a series of coupled first order differential equation or difference equation representing the behavior of the system's state, and an equation that relate the state of the output of the system. Yeah, the state is a set of variables associated with energy storage or memory devices in the system. So energy storage devices means inductor and capacitor. If in our system, if there is an inductor and there is a capacitor, definitely we can generate the states for them. So that's all. These are the four methods of representing the time domain representation of linear time invariant systems. So thank you so much for your careful listening, and please like this video. So if you like this video, it will reach so many people who are in requirement, and please share with your friends and family so that they can also get the knowledge of this video. And please, if you haven't subscribed till date, please subscribe to my YouTube channel and kindly press the bell button so that you will get the notifications whenever I upload any video. Thank you so much.